Hello everyone, welcome back to the Game Engine Development Workshop series. So last time we really dug into our scripting language here, and we got most of the instructions written actually. Just some basic math, some bitwise stuff, some math functions, and then all the memory stuff. So today we just have like a couple more basic essential instructions to go over. The like control set, so like branching, jumping, calling, all that stuff. And then once we're done with that, which should be pretty swift, we will move into integrating this with our engine. So there's sort of two components to that. The first is just like getting input from the engine. So like, is this key pressed? Is the mouse button pressed? What's the mouse's position? And then the second part is more complex, which is like hooking this all into our like dynamic system, and so that we can actually manipulate objects in our world. So the goal by the end of today will be that we have all of this stuff in here, like this hard-coded stuff controlling our movement, will all be done in a script. So that'll be done for the player, and then camera-wise, this will be running a script as well. So we won't have like the behavior here hard-coded. It'll be a script where we have the target and we get the target's position. Da 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 da. Okay. So let's just start out with the control stuff. Sort of just going to blaze through this. Quite a few of them are very similar. Like the branching ones, we have like branch if equal, branch if not equal, greater than, all the different kinds. So this should be pretty fast. So branch if equal will take two arguments. I'll go to the spec here. So two registers of any type, compare equality, and if they're equal, it will jump to this, like its third argument, which can be a label or an immediate. Okay. So obviously, if we're jumping to some instruction, we need to make sure that that instruction is valid. So we'll do a range check on that. And the reason I'm only checking the immediate integer there is because this doesn't accept, the third argument doesn't accept an integer register, which maybe it could. You could do that if you want. I think that's kind of weird, and I don't really know when you'd use that. But this only accepts integer immediates and labels. And if we look back at our parser real quick, we will see that labels are just replaced at the end of the day with like the value of the line they are, and that value is stored in the immediate field. So that's why we only have to check that. Then now that we know that we've got like a valid jumping index, we will just compare the arguments we were given. So this takes, or these two arguments take a register of any type. So we'll have to do sort of a a doubly nested guy there. Oh, whoops, what'd I do? So we get the left-hand side and then the right-hand side. If they are equal, set program counter equal to the given location, and then we'll subtract 1. And the reason we subtract 1, it's not in here, it's going to be in script.run, is because these instructions are run by this line here. This like confusing line is what actually runs these functions, and then after that, the program counter is incremented. And so if we want this to be the next instruction we go to, we have to account for the fact that it'll be incremented right after this. So we do -1 there. And the beauty of all of this is that we've like overloaded the equality operator for our vectors, so we can just compare them as integral types, just like our integers and floats there. Okay, and now we'll just do a bunch of copy pasting pretty much. So we have equal, and we want not equal, or equal to 0, which is useful, not equal, less than, greater than, less than equal, greater than equal. So branch if equal to 0 is just sort of like a common case that you'll have, is you'll want to check something is equal to 0, and that just saves you like the extra hassle of having to load the value you're checking against into another register and comparing those. You can just compare it directly to 0. Okay, and then branch not equal. Let's replace that. Branch less than. That, and branch less than will actually, these sort of ordered operators, I guess, the less than, greater than, will not take in vectors because, well, I mean, we haven't overloaded those operators for our vector class, but also I don't know how we would. Like, I don't know, I guess you could do by magnitude, but I don't know, it just seems sort of arbitrary. So for these last ones here, we will not allow vector arguments. And I'll just copy that actually. Okay, less than, greater than, less than equal, greater than equal. I'll do greater than. Just flip that sign around. Less than equal, just add an equal. Greater than equal. Okay. So those are all of our like branch things where we take some arguments, compare them to some other value, either another argument or just 0, and then depending on the result of that comparison, we jump. Next, we'll just have like a straight up jump, just an unconditional jump. So this just takes a single immediate value, and we'll jump to that. But of course, we also have to check if it's valid. And I can just copy this line. And this line as well, actually. Nice. Okay. Then we have our like function instructions, I guess. Call and return. So call it's basically a jump, but it has one extra step. So we check that it's valid and then set the program counter to the value. But based on our discussion, I think it was 2 videos ago now, we are also going to manage the stack pointer, or sorry, not the stack pointer. We're going to manage the return address directly as part of this instruction by just pushing it to the stack ourselves rather than making the programmer do that. So our return address will be the current value, the current instruction we're on, and then once we've pushed that, we will set the new location. And then return will be basically just the opposite, where we'll just take our program counter and set it equal to whatever we pop off the stack. Okay. We'll have a very simple instruction just to end execution just by setting abort. And that will sort of break out of this loop because while not abort. Okay, then we have 2 that I think could be useful. They're certainly not difficult to implement, so I just went ahead and did it. But I can't really think of a specific use for them. We have sleep and then block. So sleep will sort of stop the current execution. So it's going to set abort equal to true. But it'll also set im sleeping equal to true. And this will... This instruction makes it so that when it's hit, when this instruction is run, it will sleep this script, like this script will stop executing for the given number of milliseconds, but all the rest of the script, like this script just returns its current execution. or returns from its current execution, but everything else keeps running. And then once the given duration is passed, this script will resume from the point where it slept. Not from like the entry point or the beginning, from the point where it stopped. And so we'll set also sleep end, which tells us like the time at which to resume executing this, because the assumption is that this is like hooked into the rest of the engine environment in such a way that script.run is being called like every frame. And so we sort of can just like move some of the work of managing when a script is actually run into this file, rather than making like classes that are scriptable implement this themselves by saying like, hey, okay, I used my item. I need to keep track of like when the next time I can run my script to use the item again is, because I have some cooldown, some number of milliseconds. And that's just boilerplate stuff, right? Like it would be the exact same for every class you want that functionality in. So we can just sort of move it into this class ourselves and then take care of it all in the run function, just so this can still be called every frame, just make it a bit more convenient. So we'll take the current time and add either an integer register or an immediate that we've been given. Next one we have is not as useful, I don't think. This is block. So block, we'll write a new function called math.sleep. And this will just block all execution of the whole program for the given number of milliseconds. And again, not entirely sure when this could be useful. Certainly not for like things that run very often. Like you wouldn't use this in like a player control script or a camera control script, or probably even an item. But it could be useful for like cinematic things, maybe. I'm not sure. I don't know. Again, I just sort of implemented this because why not? It's like one line. But in our math core file here, we'll go ahead and write that function. I'm going to include the thread header. So this should be a platform independent way to like pause execution. I think it is. So we just take in like a millisecond number here and then pause the current thread for that number of milliseconds. I'm almost certain this is platform independent, but if it's not, again, not a huge deal. Like I don't really know when you'd use this anyways. And it certainly is not difficult to do this in a non-platform independent way using either like the Unix like nano sleep or Windows just as like a sleep function or something in windows.h, I think. But yeah, that one's not very useful. Okay, now we'll take all of those and put them in here. Like last time, I'll just open up my version that's already done, so I can just copy paste them. And you have the spec, so you can write these yourself, and you also have the ability to pause the video, obviously, so you can see what they actually are. Okay, so that is all of like the basic sort of instruction set we have here. We can do just about anything you'd want to do as long as it's not integrated with the engine. But I guess we might as well go ahead and test these. So we can write like a simple loop, maybe. So let's say like we want to loop from 0 to 5 and print out all those numbers. So we can move 0 into T0, then have a loop label here, and then if, or we'll move 5 into T0. And if T0 is equal to 0, we will jump to exit. That'll be our label down here, which will just be the end of our program. Then we will just print out T0, decrement it, and then jump to loop. Okay, so I think I have this set up to run. Yep, let's see what we get. Should get like 5, 4, 3, 2, 1. And there we go. So that's just a basic for loop, essentially, or a while loop. And for fun, we can do some like a proper function call. I don't want to write a whole fib thing because that's like a longer ordeal. So I won't do anything recursive. But let's say we want a function called print, and this just loads, whatever. It'll just print whatever value it's been passed, and then return. I have main, which we will move. Let's say we want 10 to be printed, so we'll call print, and then end. And that end isn't really necessary, so we can leave that out. But here we'll also be able to see that our entry point system works, because our parser will look for this main label and say, okay, I'll start here, instead of just at the top of my script, which obviously is not what we want. So this should just print 10, and there you go. Yeah, I don't know. There's not really like a way to prove that this works completely correctly unless you do recursion, but I'll save that till later on. Okay, so now at this point, we're just going to start like going through our engine code and sort of updating it to work with these scripts. And this kind of gets messy. To be honest, like I haven't thought through it 100%. Most of the reason for that is that like the way in which you would actually integrate these scripts into your engine probably would depend on the type of game you're making and what kind of things those scripts need to be able to do. But what we'll just do is sort of brute force our way through it to the point where, as I said, we can achieve our goal of just controlling our player and our camera with a script instead of this stuff in our main loop. Okay, so first we're going to go to world. Update this just slightly so that it stores an engine instance. Like that. And in our core file, should be good. Okay. I think we'll add one more method here, because we only have isMouse left and isMouse right. So we'll add just a generic one, isMouse pressed. And we'll also have to implement this in our graphics core. Not that one. Graphics. Because we have, what do we, yeah, we have isMouse. Okay, yeah, we'll just write another function, so. This could be useful if you, like, I don't know, want to check if the mouse has, like, thumb buttons or something. But the main point is that we have these main two mouse buttons and then just a key pressed, and, like, the mouse position and scroll and stuff. Okay, so with those simple changes, we can now write the, like, input stuff that we need in our script. The input instructions. We'll just do another quick one that could be useful. That's not input related, really, which just gets the current time and stores it in a register. That could be useful if, like I was saying with the sleep thing, if like you want your script to control when it's run, essentially you can, or when it's time to do a certain action. So like if you have a player script and you want it to run all the time, but you only want to be able to shoot some projectile like once every second, then you could use getTime to make sure that that will only shoot once every second. But the main thing here is engine.input. So we will have a couple functions. I'll go to the spec. So we have input mouse position, input mouse scroll, input mouse button, key pressed, and key difference. So key difference is just sort of a convenience. This is because, as is like often the case, clearly, it's very useful to determine the difference between two key states because you can like figure out movement that way in a very clean and simple way. So we'll just have sort of an instruction just for that. So mouse position. I think it was called get cursor pause. Let's see. Yeah. Oh, forgot to, in world, we should, just for convenience, friend class script. And now we can just access that. That's not necessary. That's part of what I was saying about how this is like kind of messy. I just did basically the bare minimum to get something cool working. And then that, oh, actually, no, yeah, we don't even need that. We can just assign that directly because that returns a vec2. Okay. Then we have mouse scroll, which is basically the same thing, just get scroll. Then we'll have button. This will store it in an int register because it's just a Boolean. Just call that new is mouse pressed. And you could certainly very easily add specific instructions for left mouse and right mouse if you wanted. We'll have is key pressed, which will be kind of similar. Very similar. And then key difference. So this will get the state of two keys at once. Call them A and B. And those will be stored in the 0th and 1st register. And this one will actually, this is the only instruction where we'll be using both of those immediate values. Just because it, like, when you have this, you know, A minus D, it doesn't really make sense to have to load one of those values into a register, so it'll just be nicer to say, like, key difference of 65 and 68, just both constants. And then we'll store the result of A minus B in the 2nd or the 3rd register. Okay, and we'll add these down here. I'll just copy and paste. IKD. All right. So to test these, we actually will have to be running our script like within our game loop. We can't just run it as a one-time thing. So let's set this up a bit better. I'll just take this run and put it, oh, I don't know, somewhere in here, down here, I guess it doesn't matter. Then we can use the print function. We'll do IKD of, we can do A and D, so 65 and 68. store that in A0, and then call print, and see what we get. So this should print out 1 when I'm pressing A, and -1 when I'm pressing D, and 0 the rest of the time. So I have 0, I'm pressing D now, not getting anything. Huh. Interesting. Not getting anything. I'm not sure. Could be an issue in this method here. Is key pressed? It looks right. Let's just try this one. Maybe I messed something dumb up. This should just print 1 if I'm pressing A. Okay, so that works. So yeah, I just messed something up in that IKD instruction. Let's see. I'm not sure actually. I'm not sure. I'll ignore that for now, and I'll get it working for when I push the code to GitHub. Probably just something dumb, or I may have like skipped a step in the parser, maybe where this constant is not being loaded into. Actually, it might be that. Let me see. Oh no. Okay, I don't know. I'll figure that out. But the important part is we got the key working there, and then we can also do modify our print function here to print. Gosh, I haven't done this. Let's see which argument is dedicated for vector. Okay, so A6 is a vector argument. So print A6, and then we can load mouse position into A6 and see what we get. See there, if I go here, it's 0, 0. All the way down here, it's, what's that, 800, 600? Yeah, pretty cool. Right, so those input ones work. Now we have the much larger task of object manipulation stuff. So as a like convenience method, we'll add one last thing in math.core. So this will just take a map and convert it to a map of a different type, because that's not like, none of the standard like casting operations work on that, even when it is a totally valid conversion, which is annoying, but it's an easy enough method. Okay, and this will be used in the equally as hacky scriptable class. This is just like a base class for anything that can run scripts. And we'll use that cast map function to, well, you'll see. So a scriptable will store actually quite a lot of stuff. So each one is going to have a position, a dimension, and a velocity. They'll also have a list of named scripts. And then a list of or not a list, but a map of these same names, like the name of each script to the return value, the value returned by the last execution of that script. Because remember, script.run returns an integer, which is just the flags register. And then we'll store a map of strings to states. And this is like we'll replace the one we have in dynamic right now, which is string to sprite pointers. We'll just use this. And there's definitely a better way to do this with like template stuff, but I didn't think that far, so we're just storing void pointers, just like a generic whatever type. Okay. We'll have two private methods. One called run, which will run all the scripts that this scriptable contains, and it'll return this mflags map. So it'll return a map containing the results of all of those scripts being run. And then we'll have a get current state. Which will just take in the type that we want to essentially use our states as and return that. So even though it's void pointers here in dynamic, obviously we want it to be a sprite pointer, so we'll just call get current state and pass in as the template argument the sprite type. We'll have our constructor, which will take a whole bunch of stuff. Position, dimension, velocity, speed, the list of scripts, the list of states, and then the current state. And we'll basically just copy all of this over. Here's where we'll use that cast map method. And I realize I forgot speed. Okay, so this is templated just so that it can take in an unordered map, like the states of any type, but then ultimately it converts them to void pointer to store them. And again, super messy. You should do this with templates. Okay, now we'll just have like a bunch of getters and setters. The first one we'll do is has, which will take in a string and return whether or not this scriptable has a script with the given name. And this is not, like we're not going to use this, but I think it's sort of a cool design choice that I've thought a bit about using in my own engine, which is that like in order to avoid having to classify different types of objects in like a concrete way, you can just sort of standardize, like have some standard naming convention for your scripts. And then if you want to check if a certain object can do a certain thing, you just check if it has a script with that name. So say you have some like vehicle or something that you want your character to be able to drive around in. So then when your character walks up to the vehicle and performs some action, like presses a button or something, then they will have a script called vehicle control or something like that. So they'll be able to interact with it. But like an NPC won't have that script, and so it won't be able to interact with it. And this is something that I think is pretty powerful, or would be pretty powerful in terms of like development cycle. Just because you don't have to come in and hard code like all of these different classes of characters that can all do different things and have like multiple inheritance and all that ugly stuff. You just have a map of named scripts, and as long as you follow some naming convention, you can make sure that certain objects can do certain things, just based on the fact that they have a script for that. So again, we're not going to use that, but I just thought it would be cool to share that. We'll have getters for these three. Call that getDims. Okay, then we'll have setters for our three vectors, or well, two vectors, set, position, and velocity. And I guess you could have one for set dimension as well if you wanted, but I couldn't really think of a situation where that would be used. And here we'll do the same thing that we're doing in the dynamic class, which is just clamping this to the proper range defined by our speed, like our maximum speed. And then we can do this other thing, which is if our mvel is 0, which we can define, then we will actually set it to 0. And this will be in, no, not in core, in vec2. So this will use the is0 method from the core file, which if you remember is like not a strictly equal comparison. It has like some wiggle room. And I think that's useful for velocity because if stuff is moving very, very slowly, it's basically not moving at all. So you can just stop it moving altogether, and that can speed up stuff like your quad tree. Just for example, if you have a bunch of things that are moving very slowly, you don't even need to check all of their, like you don't need to check their collisions because they're not going to hit anything. So you just say, okay, you're not moving at all. So we'll return if both of our components are 0, x and y. Okay, so that's our set pause and set vel functions. Next we'll just have set state, which actually is probably exactly the same as dynamic. I'll find that and just copy it. Probably could have done that for a lot more of these. So we look for the given state. If it exists, we set it. Otherwise, we just print an error. Okay, so that's most of our scriptable. There's a few things we have to define in another file, though. Have our destructor and our run function. So our destructor will just go through all of the scripts we have in here and delete them. And this is, again, sort of a weird choice. Like, it would probably be good to have some sort of like script management system, not like independent of scriptables, so that sort of like what we have with like our sprite bank, just a very simple thing that like maps file paths to different sprites. But whatever. Okay, and then the run method, we will just clear everything in our flags array. No, not array, map. And then for each script, we will run it. And we run it with this scriptable as the host object, which will be important in a minute. Okay, so now that we have this, we can sort of convert our dynamic and camera classes into scriptables. So we'll just have them extend from that. We will also create a simple struct called dynamic template, which is sort of like our chunk constructor, which will just store everything we need to create a dynamic. And this will allow us to like define templates, like patterns for dynamics, that then we can spawn via our scripts. Okay, so we'll inherit from scriptable, and then we'll just add on another thing to this super huge ugly constructor. But also then create a new constructor, which will take in a dynamic template. Okay. Oh, and one thing I noticed here is that we're not actually... Oh, wow, that's pretty terrible. We don't even have a destructor. We're not deleting our hitbox. Oh well, now we are. So we can move or remove a bunch of this stuff. We don't need set state, we don't need get current dims, or these, or that, or that. We can still have get current sprite, and we'll just return get current state. What is it called? Our scriptable, we have, yeah, get current state. Oh, I made this private. That should be protected. There we go. Get current. There it is. Get current state. I'll cast that to a sprite. Just return it. We still need to get vertices, but we can remove a bunch of this stuff. We don't need that anymore. We don't need to store our own speed or this stuff. But what we will do is, so we'll have this sort of problem with our like spawning in new things, which is that when we spawn something, if we like create a new dynamic immediately and sort of add it to our world and our quad tree immediately, it might be inside of something, because our spawn command, all it's going to take is a string, like the name of the dynamic to spawn. So like we'll just have a sort of like our sprite bank does. We'll have a simple class that has a map of strings to dynamic templates, and so we'll give a string and it'll create a new dynamic from that template. But that's all it's going to take. We don't have enough room in that like argument list to also specify position, velocity, all that stuff. So that's going to happen in subsequent commands after the spawn command, which means that when we create something, we don't want to immediately add it to our world, because it might be inside of stuff, and that's going to print errors. So this is what our spawn queue is going to be used for in our script class. This thing. So when we call the spawn command, we'll add new dynamics, we'll create new dynamics and add them to the spawn queue. And then at the end of our run function, so after we've exited this, execution loop, we will go through that whole spawn queue and actually add everything in there into our world after all of its values have been set properly. So that's what this bool add is, specifying whether or not we actually want to create it. And to accompany that, we will have a method called add2 that will be called to like actually add this thing. And we'll also just store whether or not it's been added. Okay. And then our two constructors here are going to share quite a lot of functionality, so we'll just have void init. They can both call that. Okay, so we've got this thing, it's a new constructor, and we also changed this one a little bit by adding a new parameter. Now they both have to call the parent scriptable constructor. Okay, so this is sort of what I was saying about how when we create stuff from our scripts, their position is going to be set to 0 and their velocity is going to be set to 0. So they might be, inside of something else. Why is this not happy? I'm not sure. This one, oh, I didn't copy that whole thing. Also need to convert this to use the parent constructor. And here we'll also call init, and then init will just do what this constructor is already doing, basically. So set the state, then update dimensions, update vertices. And if we're adding it immediately, actually create a hitbox. Okay, so that's a init. Oh, we have another function which I forgot to add, which is run scripts. And this is an, where is it? Here it is. Yeah, so we have run here. There should probably, I think we should enforce that this method should exist, run scripts. So I'll give it a virtual okay. So we'll make sure that it exists, and then under the hood, that'll call this protected run method, which actually does the running. But this will, the run scripts method will be, its job will be to like determine what the environment is basically, because that's a big component of running the scripts is what does the script have access to. And for us, as I touched on, I think last episode or something, our dynamics are going to consider nothing as part of their environment just by default, but our camera will say its target is part of the environment, meaning that the camera control script can also access data from the target and manipulate the target itself. Okay, so we have that virtual method here. I'll just copy that. And then in dynamic, do an override. Okay. So this will be called every frame, like run all the scripts every frame. And for our environment, we don't actually store anything, right? But we need to pass something. So we'll just create an empty vector. And again, this is pretty messy. Probably what you'd want to really do is like have the script.run function instead take, because right now it takes a reference to a vector. That should probably be a pointer to a vector, and then you can just pass a null pointer if you want an empty environment. That would make more sense. Okay, then move hitbox. We can just get rid of that and replace it with mdim. What else we got here? Set state. We don't need those anymore. Okay, so that looks about right. This one's still yelling at me though. Speed script state. I'm not sure what it's not happy with. I don't know. We'll figure it out later. Okay, so that's it for like modifications to our dynamic class. Next, we will set up a system for handling dynamic template stuff. Because like I said, we need some system to like name these so that we can create them by name from our scripts. So we'll just do a very simple system similar to our sprite bank. Okay, so we'll have a put method, which will take everything needed to create a dynamic template and then actually create one and return a pointer to it. And then we'll have get. Then all this is going to be under the hood is just a map of strings to templates. Okay, so when we add a new one, we should go ahead and check that like it's a unique name, just so we make sure we're not overwriting anything. Then return a pointer to it. Not sure why it doesn't like that. Ordered map of string to sprite pointers. Oh no, scripts. Huh. Oh. Well, there you go. All right. Get will just basically do the same thing. Just check if it exists. If it doesn't, print an error. And return null pointer. Otherwise, return pointer to it. Okay. Before I go on, I'll just quickly compile, just so a bunch of dumb errors don't build up. Okay, we have get current dims is not, can just be get dims. And then this, which we're getting to. Okay, good. Okay, I think I'll start closing some of these files. This is getting crazy. Oh, why did I name that dynamic template? That should be dynamic bank.cpp. Yeah, all right. So next, now that we have our dynamic class with this new run scripts method, we need to make sure that this is actually called every frame. So we can do that in our draw group class. Just by adding another method like that. So, just go through the whole list, call a run scripts on each one. Now we also need to hook this into the dynamic list class. And this update function, instead of just taking in the delta, it'll take in a whole script runtime, which includes a renderer, so the delta can still be gotten from that. Probably need to include that again, script.h. So delta is rt.render.get frame delta. Okay. And then before we perform any movement, any of this other stuff, we will run all of the scripts, because those will likely control movement in some way. So before movement is performed, we need to know what movement needs to be performed. Okay. Now I'll compile once again. Right, so in world.draw here, we can just create a script runtime. With the given renderer. And then pass it in there. So I need to include it again. Okay. And this create dynamic, what's wrong with this? I think it expects a map of scripts. I don't even know if we should maintain this. Like, we're probably not going to use it, but just for the sake of everything compiling, I'll just throw an empty map in there. Okay, so now we'll sort of like round out our dynamic stuff here before we move on to the camera, with just like a dumb example class of like how that sort of thing I was talking about earlier, of this named script system where you can determine, I guess, the type of some object based on what scripts it has. We'll do one called character. And it's just going to be a dynamic. And it's going to require a script called move. So there has to be some way to move this object. And then it's just going to take the rest of... man, this is really a mess. This is so hard to read. This big ugly one. This one is much better. But it's just going to take the rest of this stuff. And then all it's going to have in its list of scripts is one called move, created from the given file path. Called list, and then I guess I need to include that. Okay, so this is what we'll be doing. We'll be using this to like replace our just basic dynamic that we have in the main file now, just passing in our script as its move script. Again, this doesn't, there's no reason to do this right now. I just thought it would be helpful to illustrate what I was talking about earlier. Okay, so that's all of that done. Now, the next thing we have is just making similar updates to our camera that we just did to our dynamic stuff. Let's turn that into a scriptable so that we can attach a script to it. So get offset. We don't actually need to store that anymore because we have position, so we'll just return position for that. And then update. We'll get rid of that and replace it with, we just copy paste it, we'll replace it with an override of run scripts. I'll move that up here. And all that's going to do is run the given runtime, and the environment that we'll store, which will just be a vector of scriptables. And all this is going to contain, again, is our target that we've been given. But I'm actually I'll just completely rewrite this constructor here. Similar to our character that the character class we just made, we'll have the requirement that every camera needs a script just called run. So we'll take in a file path for that. We need position, velocity, speed, and finally the target. So this one, for a camera, it doesn't really make sense for it to have dimensions. So I'll just pass 0, 0. We'll just add our target to our environment. I'm not sure why it doesn't like that, but why doesn't it like this? I think I just forgot some stuff. Yeah, so our camera won't have states either. And this is where you can really see the messiness. It would probably be best to have sort of several different types of scriptables that all have some truly core base functionality. Like our dynamics, obviously that needs states and that needs dimensions, but our camera, which should also be scriptable, doesn't. But I've just done it all under one thing. I'm not sure why this is yelling at me. So our dynamic is a scriptable. So I'm not sure, but whatever. We have our run scripts function there. We have get offset, which is just sort of an override. And we can remove that, actually. We don't need that. We can just use get pause. Okay, at this point, again, I will compile and see what I've broken. Okay, here we'll replace with get pause. Undefined type. Actually, does script include scriptable? It doesn't. We could make it, but whatever. Okay, undefined type script, but then I'm not sure why it's not letting me push that back. Maybe because it's const? No, definitely not that. Guess we could just make it so this targets another scriptable. That kind of makes sense. Oh, but it's still not working. Argument types are const. Oh, this is marked const. That's weird. Not sure why that was. Okay, there we go. Build once again. Just yelling at it about it in main, and then update, of course, is no longer called update. It is run scripts, which takes in that. Okay, so that's our camera done. Now we'll sort of loop back around for the finale and integrate all that stuff we did with the dynamic and the character and the dynamic templates into our world, just like add some temporary functions like these, so that we can create them with our main file just for testing. So we'll have create dynamic template, which will take in all the stuff needed by this function. Just be a wrapper for that. It's not spelled right. Dynamic template. Okay, then we'll have another create dynamic. I really can't spell that. Create dynamic for our new system where they're going to be created by the script. So all we need is a name. And then we'll have one last one for create a character, which will just take in all of that stuff. Okay. Let's define these. Do I also not have script class? Okay, so I include script there. I also need dynamic slash character. Yep. These are just going to be super simple wrapper methods. So create dynamic template. We'll put a new dynamic template in our dynamic bank, which we don't have yet, but we'll do in just a minute. And create dynamic, which will find the template with the given name. And if it exists, create a dynamic from that template. Okay, and then create character. Again, just a wrapper for the constructor. Okay. All right. One final compile here before we go to our script and write the instructions to make use of this. Do you see one error here? Oh yeah, okay, we'll update that later. Okay, so our last couple instructions will be to manipulate objects. And I'll define a macro here. Current scriptable. Which will just check the value in the object register. And if it's equal to like the special host value, it'll return host. Otherwise, it'll return an object from the environment. Okay, let's look at the spec real quick, just so we know what we're doing. So we have a couple methods here. Get pause, get velocity, set velocity, get dimensions, get speed, set state, and then finally spawn, the big one. So get position, we'll just take in a single vector register. And set the position to that, the position of the currently bound object, which is something I'll sort of demonstrate what that means when I write an example script. Set position will also just take in a single vector register and then set the position of the currently bound object. Then we have velocity, which is much the same. Then we have get dimensions. Then we have get speed, and finally set state. But get speed is just a float, so we don't take a vector there. And then state is set state is a bit more involved because obviously our states are named by a string. So we'll sort of copy what we're doing up here with our debug where we're reading at a position in memory as a string. So I'll just copy this. We'll call set state on that string. And this is the reason that we did this whole thing with like abstracting stuff out into scriptables, just so that everything that runs a script has this common interface of like it has states, it has position, velocity, dimension. Because like again, it doesn't really make sense that a camera would have a state, but still this expression needs to be valid regardless of the actual type of object that is currently bound. As long as it's a scriptable, this should be valid. Okay, and finally we have spawn, which I think I'll actually do in a minute. I think we'll just test these out first, and then come back and do spawn. I'll just copy these descriptions over as I have been. Okay. And now can rewrite our main file somewhat. We'll include character. We can get rid of this test script. And we'll have, we'll replace this with a character. I'll call it player. This will be world.createCharacter. And that, of course, needs a script path. So we'll create a player.script. Why is this not happy? Create character. Oh, I gave that the wrong. Oh yeah, I just copied the character constructor, but we don't need those two because our world contains those itself. That's the whole point. There we go. Okay, and then camera we'll have to change also. That needs a script now. Just start it at 0, 0, give it a speed of 100, doesn't really matter. And then it will now follow our player around. Then in here, we can finally delete all of that stuff and just call world.draw. Okay. So I think I'll just create these new scripts, but not actually write anything in them, and then we'll see what the results are. So I'll have player.script, and then camera.script. Okay, we've got those. They're both empty. We can close test. Let's see what we get. Oh, some errors. Oh yeah, this does need to include scriptable. Run scripts must return a value. Of course. Cannot run a script that failed to compile. Oh, I called it cam. Camera. Okay, so we now have this, and we can't do anything, which is exactly what we'd expect. So like, it's all running, and technically all the scripts are happening. Just to prove that that's the case in our player.script, we can like debug just some string just to see that it'll now print test every frame. You can see that's coming from our player script. So it's actually going to take some time to write this player script, and then we still have a bit of work left afterwards to like implement the spawn command, and we'll do some testing with that as well because it's kind of cool. So I'll sort of leave that for next video. So next video will just be fun. Like we're done actually writing all the C++ code now. We'll just be working on scripts. And so that'll be sort of like a wrap up, like finale video. Yeah, so I'm looking forward to seeing you then.